Yes.
Good morning, viewers. I am Saraswati, working as an assistant professor in the Department of Computer Science and Technology in SMS College of Engineering. Now we are going to teach about the topic is real-time operating system. The real-time operating system is one type of operating system mainly used for a real-time application. These are having two different types, such as soft real-time operating system and hard real-time operating system. These are our mentees. The mentees now explain this topic.
Topics of discussion. What is RTOS? Comparison between RTOS and general operating system. Types of RTOS. Characteristics of RTOS. Functions of RTOS. Applications of RTOS. Examples of some RTOS. Conclusion.
What is real-time? Real-time in operating system. The ability of the operating system to provide a required level of service in the bounded response time. What is RTOS? It responds to inputs immediately, real-time. Here the task is completed within a specified time delay. In real-time situation like controlling traffic signal or a nuclear reactor or an aircraft, the operating system has to respond quickly. What is RTOS is not. Real-time computing is equal to fast computing. Real-time system operate in a static environment. Real-time programming involves assembly coding, priority interrupt programming, writing device drivers.
Soft RTOS. In soft real-time operating system, it considered undesirable but catastrophic if the deadlines are occasionally visible, also known as best effect system. Most modern operating systems can serve as the base for a soft real-time system. Example: multimedia transmission and reception, networking, telecom and network, websites and service, computer games. Hardware operating system. A hard real-time system has limit time critical deadline that must be met. Otherwise, a catastrophic system failure can happen. Absolutely positively first time, even every time. Regularly formal verifications of being to always met in hard deadlines. Example: air traffic control, vehicle subsystem control, nuclear power plant control.
Characteristics of RTOS: consistency, reliability, predictability, performance, scalability. Functions of RTOS: task management, scheduling, resource allocations, input handling. Task management: in real-time application, the process is called as task, which takes execution time and operates manually. Task management is the process of managing tasks through its life cycle.
Task process varies. Each task process can belong to one and only one stage. The scheduling only operates on the process in the ready state. There is a single process in the run current stage at any time. Tightly task operation: creating and deleting tasks, controlling task scheduling, and optimizing task information. Scheduling in RTOS: more information about the task per number of tasks, resource requirements, execution time, deadline. In a more determined system, better scheduling algorithm can be derived. Scheduling algorithm in RTOS: clock-driven scheduling, white round-robin scheduling, priority scheduling. Scheduling algorithms in RTOS: clock-driven, all parameters about job known in advance. Schedule can be computed offline or in some regular time instance. Minimal runtime overhead. Not suitable for many applications. Scheduling algorithms in RTOS: weighted round robin, job schedule in FIFO manner. The time quantum given in job is perpendicular to the weight. For example, high-speed switching network, QoS guarantee. Not suitable for considered jobs. A job A can run only after a job B. No point in giving time to quantum to job A before job B. Priority scheduling: processor never left idle when there are ready tasks. Processor allocated to process according to priorities.
Resource allocation in RTOS. Resource allocation: the issue with scheduling applicable to a resources can be allocated in weighted round robin priority based. Some resources are not permittable, example semaphores. Priority inversion if priority scheduling is used. Other RTOS issues, interrupt latency should be very small. Kernel has to respond to real-time events. Interrupts should be disabled for minimum possible time. For embedded application, kernel size should be small, should fit in code. Sophisticated features can be removed, no virtual memory.
Interrupts handling in RTOS. An interrupt is a single form of device attached to computer to perform a program within a computer that calls a main program in OS. To stop the figure out what to do next. Interrupt causes the processor to suspend the operations whenever it is doing, instead execute the code that will respond to the event whatever caused the interrupt. Application of RTOS. Almost all the modern telecommunication systems make use of RTOS. Radar system, network switching control system, satellite monitoring, satellite launch control, global positioning system all have their roots in RTOS. Nowadays, RTOS are increasingly finding use in strategic and military operations. These use guided missile launch units, track and track spy satellites.
Microkernel. Several types of semaphores. Binary, counting, mutual execution with priority inheritance. 256 priorities. TOSIX complaint. Microkernel features. High scalability, incremental linking and loading of components, fast, efficient interrupt and exception handling,